Okay, so we've got a relative velocity problem here. Okay, so we've got a cruise ship that's moving north at this speed, and we've got a puck that's being slid from east to west across the deck at another speed. Okay, and so we're looking for the relative velocity of the puck with respect to the water. Okay, so we're given the velocity of the puck with respect to the ship, but we want it with respect to the water. So this problem becomes really simple whenever you realize that this is just, they're giving you two vectors and they just want you to add the two vectors together. Okay, because in this case, the relative velocity would be, so this is the vector of the relative velocity, would be equal to the vector sum of the two vectors. Okay, so I'm going to call the east to west velocity as v sub x, and I'm going to call the north velocity v sub y. Okay, so y and x for the direction. Okay, so let's go ahead and first look at how we add the two vectors together. Okay, we're going to do it graphically. So that arrow right there represents v sub y. Okay, so that is our north velocity. And then I'm going to draw another arrow pointing to the west. Okay, that represents our horizontal velocity, or v sub x. Okay. All right. So our resultant, okay, or our relative velocity would be an arrow like this. Okay, so it is the vector sum of these two vectors. Okay, so now, so how do we do that? Well, what we're going to do is we are going to come down here and draw another picture where I start with my first vector. Okay, and then what I do is I take my second vector, okay, and I stick it over here on the, basically stick the beginning of the vector on the end of the other, okay, and so that would give us our resultant, whoops, like that. Okay, sorry for my terrible drawing skills. Again, that's the same resultant vector, only this drawing is here to show you that the resultant vector is the hypotenuse of the triangle created by the two vectors. Okay, so we know the magnitudes of the numerical magnitudes of the vectors, and so all we have to do is use Pythagorean theorem to figure out the magnitude of the relative velocity vector. Okay, so let's see here. So let's state the Pythagorean theorem in terms of our variables. So the two legs, right? So v sub x, and I'm just doing the magnitudes here, plus v sub y, okay? And they're both squared, so v sub x squared plus v sub y squared is equal to the hypotenuse squared, right? Or in our case, that's the relative velocity squared, okay? So let's go ahead and solve for the relative velocity. Okay, so that'll be the square root of v sub x squared plus v sub y squared. Okay, and then let's go ahead and plug our numbers in. Okay, so that's the square root of 4 point, I got them backwards, so I'm doing Vy first, but that does not matter because it's a sum. Okay, meters per second squared. That's quantity squared, by the way. Okay, plus 8.37 meters per second quantity squared. Okay, and once you plug that all that into a calculator, I'm going to come out here, right? We get the relative velocity is 9.41 meters per second. Okay, now that's not quite it because we need direction, right? Because we are still looking for a vector. So the vector would be, since we're moving north and then we're moving east, I'm sorry, we're moving west, our direction would be northwest. Okay. All right, I hope that helps answer your question.